So we're doing translations 5-1 on sapling. So translation, so if we're talking about translation, that could be rigid or not rigid, but we're gonna get there, so let's not jump the gun here. So transformation is a function that creates a replica of a figure. So you start out, for example, this way, and you make a bigger triangle, and that is a transformation. So you start out with a small triangle, you make a big triangle, that is a transformation. And if you were to start from a big triangle and transform it and make it a small triangle, that is also a transformation. So pre-image, that is the original figure. The image is the figure that is produced. So that's the aftermath after you transform it. That is the image. So pre-image is the original, image is the transformed image. So triangle ABC is the pre-image, and triangle A prime, B prime, C prime is the image. So prime notation is the system of naming transformed points, like what we just talked about. So it started out with the pre-image A became A prime, B prime, C prime. So point A becomes A prime. Double prime is used in a second transformation. So let's say that if we were to have another transformation after this triangle with a bigger triangle, that will be A double prime, B double prime, C double prime, something like that. So translation is when every single point is shifted by the same distance and in the same direction. So it's when you get a triangle, for example, and you move it side to side or up and down. That is a translation. So the triangle is still a triangle, but it's moving somewhere. So that is a translation. Translation vector is the distance and direction by which a figure is translated. So if you're taking physics right now, or when you take physics, you're going to do a lot of translation with vectors just to represent where your projectile is going. Any translation on the coordinate plane can be represented as a shift in the x direction, side to side, and a shift in the y direction, up and down. So triangle ABCD has been translated, this triangle ABCD, DEF, I don't know where I'm getting ABCD from, DEF right here has been translated 1, 2, 3, you can't even see, 3, and 1, 2. So it started out right here. I know this is the pre-image because of the notation, the prime notation right there. It goes from E to E prime. So 1, 2 up, 1, 2, 3 to get to the new destination. So translated 3 right and 2 up. Coordinate function notation
Teacher, sorry for this interruption. Anybody that needs to be drug tested to park or participate in any extracurricular activity, those of you that missed the first round, please bring a black or blue ink pen to the commons at this time. Please report to the commons. If you did not do the initial drug testing to park or participate in any extracurricular activities, you need to go to the commons right now with a black or blue pen. Again, teacher, sorry for the interruption.
So coordinate function notation. So how are we going to demonstrate that on the notation? So x, I know it's going to be side to side, so 3 units to the right, so x plus 3, and 2 units up, y plus 2. This is the coordinate function notation. You're going to have this on your test. So sometimes of transformations do not produce translation. You what? So it's not a translation, but it's still a transformation. So if I have a small square right here, and that square gets bigger, and it turns into this big old square, that was a transformation, but not a translation. So what happened here was it got twice as big. So from point 2, it went to point 4. From 2 to 4, and from 2, 2 to 4, 4. So it's doubling everything. 0, 0, 0 times 2 is 0. And then 0, 2, so I'm doubling all the coordinates. So 2x and 2y. So we could also flip it across the x-axis and flip it across the y-axis. It's, for example, if we have this, we're just reflecting. So we're flipping that across. So it goes from here to here and from here to here. So that is a reflection. And it's so same size as per image with different orientation. That is the reflection right there. Transformation produced by a translation. Each vertex in the pre-image is shifted same distance and direction. I think there's a sapling question over this. So just look back at your notes. So any translation can be described by the function x plus h, because it goes side to side, and y plus k, which goes up and down. When you're taking Algebra 2 next year, the h and k right here, you're going to see the very first quarter. So horizontal component h, vertical component k. Positive k and positive h goes right and up. Negative goes left and down. So rectangle plus 3 minus 2, that means it goes 3 to the right and down 2. So properties. So rigid transformation is when your pre-image stays the same in shape. You're just moving it up and down, side to side, or reflecting that. So it doesn't change the shape. Rigid transformation is not a translation. Not a translation. So translations produce congruent images. So triangle XYZ and triangle X prime, Y prime, Z prime are congruent. So, and all the parts are also congruent. So notice that the triangle just moved. It's still the same, it's still congruent.